All right, I'm going to start with the heredity notes, part 1. And I've got these cute looking little babies here. This unit is about how did you come to look the way you do. So we have this picture of the sun here because the environment has a little bit to do with it, but most of it has to do with our genes and our mom and daddy. So this picture here is going to help us visualize what does that mean when we say we get genes from our mom and dad. So this circular one here is the egg, and I can see this blue and orange looking thing in here. That is the chromosome that's in there. Very oversimplified because there's more than just that one, but at least now we can track it. So this one is for the egg for mom, and this would be dad's cell. This is the little purple and brown chromosome that's in there. So the egg and the sperm can come together to make you. So see, you have mom's donation and dad's right there into the single cell that's formed. So the very second you are formed, you are called a zygote. That's what this crazy word right here is. I kind of like it, but zygote. So the minute you are formed, you're called a zygote. That is a single fertilized egg. So it's a single cell. So you get this donation, half of you is from dad and half is from mom. So this is a haploid number and this is a haploid number. Haploid plus a haploid make a diploid. So there's some vocab for you. So haploid, I cannot write. Haploid plus a haploid is so hard. Kind of like half plus a half, with the scientific terms, make you, like di means two, so diploid. Haploid and haploid make a diploid. So there you are, your formation. Maybe a little better picture here. If you looked really close, you'd be able to kind of count. And if this is a normal healthy egg cell, there would be 23 in there. And same thing for the sperm, there should be 23 little squiggly chromosomes in there. And so when they come together for fertilization, here is the baby cell or the zygote. You can see they are pairing up already by size, and they would know what their partner is. So this little arrangement that they're doing is from big to small. So we're going to see that better here in the next frame. This one is for if it's a baby boy. Now we're going to talk about how do I know that, because part of your assignment that comes with this is going to be to look at something called a karyotype. This is a karyotype, and you're going to need to be able to figure out stuff about it. Is it a boy? Is it a girl? Is there anything showing to be abnormal about it? So let's look at it. All these little stripes should be identical between one, so that would be one chromosome from mom, and this is chromosome 1 from dad. So they have the exact same stripes, they are homologous. And maybe they determine your eye color or something like that about you. And then chromosome 2 would have to do with completely other different kind of traits, and maybe your height, things like that. So these pairs, 1, 2, 3, 4, all the way down to number 22, they affect parts of your body characteristics. So they're your body chromosomes. We would call those autosomes. So there's a crazy word, auto, like automatic, some for chromosomes. So autosomes are pair 1 through 22. But now this last one, this number 23, those are your sex chromosomes. They determine whether you're a boy or a girl. So they would have that very particular job of determining those sex characteristics for you. So here's a way to remember this. This Y is much shorter than the X. And so you always look at the very end of this karyotype for the sex chromosomes. X is the taller one, Y is short. You can't spell guy without a Y. So there it is. If it has a Y chromosome, you're going to have guy traits. So that is the male. Here is the girl on this side. I have two nice little pairs all the way down. So it looks like a normal, healthy individual here. I'm going to look at the end. This determines the sex for the individual. They are both exactly the same. They're both long, XX. So this is my girl. Okay, so you need to be able to look at a karyotype and tell, is it a boy or a girl, and is anything missing? So let's do a little practice with that. Here is one. You would look and just count. So you got 2, 2, 2 all the way down. You would count. This is a total of 46 chromosomes. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46. So all normal, healthy individuals have 46 chromosomes. What sex is it? I got 2 long chromosomes here. They're both X's. This is a girl. I see the Y here, but there's nothing here. So don't get fooled by that. How about this one? Once again, I would count. I see 2 all the way down. I don't see anything missing. I don't see anything extra. Come to the end, I have a long one and a short one. What do you think it is? It is a guy. So this is a male karyotype. So this kind of shows you how the two come together. This would be pink, obviously, so this is from an egg. An egg has 23 chromosomes, so that's why it's haploid. And then this is from a sperm cell. It only has 23 chromosomes. So if you put those two together, 23 plus 23 come together to make 46 in the baby, which is you. All normal healthy cells have 46. But what if something happens? Something called non-disjunction is a disorder where the chromosomes just did not divide quite the way they were supposed to. We can see that in this one as we're counting. I see 2 all the way down until you get here. Now you know they go together because they are the same size, the same stripe, so they're definitely number 21, but there's an extra. You're not supposed to have more than 2. So this is called a trisomy 21, but we know it as Down syndrome. So I can look at the sex of this person. It's kind of squiggly over here, but it's still long like this, so I know this is a female with Down syndrome. Do the next one, and looks like I see nice little pairs until you get right here, and it tells you trisomy. There's 3 number 21. This specific place, and it's only on 21. If there's an extra 21, then that means Down syndrome. And I look here, I see this short little Y. That's a guy. So it's a guy with Down syndrome. You got some stereotypical kind of traits they would have. They're just a little slower in the development to do certain milestones, like walking and talking and holding silverware, things like that. But they are able to have children, live normal, happy lives. Here's another type of non-disjunction. It's called Turner syndrome. And if you look, you see the nice little pairs, no issues until you get right here at the end. You have this long X and then nothing. It's almost like there's a big O right here. Sometimes you would call Turner syndrome XO syndrome because you're missing an entire sex chromosome. That's a problem, so that's going to affect her sexual characteristics. It's not going to affect body parts really because the first 22 don't have a problem, but sexual development is going to be big because think about it. During adolescence, a lot of stuff goes on. Now these case studies I found, on Google, so you could probably see those. I think it said this lady here was 35, but you see how she's very short, kind of did not develop the way you normally do during adolescence. Usually these females are not able to have children. There's some other little side characteristics. There's a webbed neck. This is before surgery and this is after. So most of those kind of things can be treated. But the problem with having children is not usually very treatable. Here's the last form of non-disjunction. We see it also affects the sexual characteristics. You have an X and an X here, they're both long, and then you have this little Y here at the end, so that's XXY. You're still going to be a guy because you got the Y, but it's going to be a guy with extra female kind of characteristics. So I tried to find the best picture I could here, but it does affect his ability to have children. Usually he's infertile. That's what that says right here. Infertility, cannot have children, and he's going to have some effeminate kind of traits. So that is our third kind of non-disjunction. Let's do some practice diagnosing some, just like you'll be doing. So you just look at all your pairs. 21 looks good, so can't be Down syndrome. I have X. Oh, nothing. X, nothing. Which one was that called? That's right. That would be Turner syndrome. Here's another one. Looks like all the body chromosomes are good. No problems here. Boom, we have an extra. What is this one called?